become link 1. Let me call this link 2, 3. Okay. So this is I12, I14, I34, I24. Now on this one here, what are you going to choose as your input link? Four. Okay, is there? Okay, let me ask again. The input force is acting on what links? 2 and 4. The output forces are acting on what links? So 1, but we don't care about 1 because that's ground. We've eliminated that. So it's only on 4, isn't it? So the output force is only on 4. So now let me ask the question again, and I'll ask it backwards. What should my output force link be? 4. So what should my input link be?
2.
Okay. So on this right here, what you're doing is you look at, so you need to look at the velocity of I24. All right. So here is 24. Great. We need to find it. So we draw this line here, and we draw this line here, and this is I24. Okay. So that's I24. Now, with 1, 2 being right here, and Fn going like that, is omega 2 positive or negative? We're pinned about 1, 2. We know the lever's moving down like that, so is omega 2 positive or negative? Positive. So your omega 2, you got a plus omega 2. If omega 2 is positive, and I'm pinned about here, what direction is I24 moving in? Up, down, right, or left? Left. So your velocity of I24 is like that. So if the velocity of I24 is moving like that, and here's I14, and here's what direction, here's link 4, what direction is omega 4? Is it positive or negative? It's positive. So omega 4 is plus omega 4. The reason why it's plus is I know that this point, 2, 4, which belongs to 4, if it's moving this way, omega 4, this whole lower jaw needs to be moving like that in order to move this point this way, so you have a positive omega 4. The other reason is that intuitively you think that you're moving up like that in order to pinch that BB. Okay? So that's why omega 4 is positive there. All right. So let's draw the line of action of these forces. So here is this force here. That's link 2. So what I'm doing is I move this thing down like this, and this right here is our in. Okay? And it's coming from the outside world towards the mechanism. So I have R in like this. I have F in like this. when I cross this into here, I get a plus Rn times F. All right. So now let's do this one over here. Here's an input force acting on the output link. So I have to move along the perpendicular here until it goes through the ground of the output link. So I have this right here as R1 out. Now, on the output link, the direction of the force is from the mechanism towards the outside world. So as I'm squeezing on the vice grip, because this is an output, is saying, I don't want you to squeeze me. And so it pushes back on your hand. It's equal and opposite. So the vice grip, from the mechanism to the outside world, your hand being the outside world, vice grip is pushing back down onto your hand, so the direction of this force is like this. So when you do this, you have R1 out like that, and you have F in here like that. Crossing this into here, you get a plus R1 out.
How do you know not to take it to the F out?
Say again?
How do you know not to take it to the F out like you did last time?
How do I?
It's like I would have taken R1 out to the right towards F out.
Oh, I'm going to do that one. I'll do that one in a second. All right. There's two forces acting in here.
Oh, we're still on.
Yeah.
Wait, I'm sorry, I'm also confused. So R1 out is from I1 out to F in?
In this case.
Why is that?
Because there are two forces. Don't get hung up on the subscripts here. There's a force here, and there's a force here.
Wait, sorry, I missed that part when you drew the arrow going down at F in.
Okay, how about I do this? I'm going to do the other one, and then I'll see if you have a question. Okay? So there are two forces on output links. There's this one here, and then there's this one here. Here's F out, line of action. This one here, from the mechanism to the outside world, so it's squeezing the stevie. So this one goes like this. And what I do is I look at moving along here until I encounter the ground for that. So here is R2 out. And so I have R2 out here, and I have F out here. When I cross this into here, I get a plus R2 out times F. All right, so let me back up. The output link, which is 4, has two forces acting on it. It has this force acting on it, and it has this force acting on it. I'm purposely covering up the subscript because I don't want you to be confused by the subscripts. Okay? It has two forces acting. One by the hand and one by the BB. Okay? So when I look at this, I have to draw it, because it's an output, I have to draw it from the mechanism to the outside world. From the mechanism to the outside world. From the mechanism to my hand, from the mechanism to the bead. Okay? That's why I draw these little diagrams on the side to see the moment contribution. Is it positive or negative? So now, what are your questions?
So the last time we didn't do the R went out to FN because that's where the ground was.
Yeah, because we eliminated that because it was ground.
That's what.
Alright. So now what I'm going to do is write the power in equals power out equation. So I have a plus Rn times Fn times a plus omega 2 equals a plus R1 out times Fn plus R2 out times F out. And that's all multiplied by times a plus omega 4. All right? Yeah.
Can you explain the F out going up?
Yep. So this F out goes up because here's the jaw here. It's an output link. Forces that occur on the output link come from the mechanism towards the outside world. So the mechanism being link 4 and the BB being the outside world, the jaw acts in this direction on that BB. So that's why that one's up. The reason why this one's down is that the hand is experiencing a force from the mechanism to the hand. That's why this one's going down.
Wouldn't it be the same though if it was going down? Wouldn't that also be from the mechanism to the outside world?
That's the graph. So that's not part of this situation.
What does that have to do with it?
If this thing here was link 2, 3, or 4, then maybe yes, this would be going down.
But isn't it just like from the mechanism to the outside world? So how do you know if it's like how does going up mean that but going down doesn't mean that?
Okay, so if I take this here and I cover all this up right here, all I'm looking at is this jaw here. And here's the D. So it's coming from this jaw going up towards the D.
The ground doesn't move, that's what.
The ground's not moving.
The ground's not moving.
And we've eliminated the, where are the vice grips? So on this here, in this case, I'm grounding this. I'm grounding this. And then I'm moving this. Okay? So here's the output link. Is coming from the output link towards that BB this way. All right?
So
Should you have drawn your arrow on the outside of that bottom arrow, like if you were following your notations, or did you mean to draw it on the top arrow?
I meant to draw it from this point of contact between the jaw and the BB going up.
how is it going, like I still don't understand how going down isn't to the outside world if it's going past the mechanism.
If, okay, let me see if I can I kind of think I see
It's
what you're
okay.
asking.
I'm just,
So this right here, if it was moving down, all right, if it was moving down, that means your omega 4 would be negative, and anything in this path right here, then yeah, it would be coming from here this way. But because omega 4 is positive, it's coming from this surface here going up. Is that helpful? Nope. All right. So that's that inversion there. Okay? So the last inversion is this right here, where let's go ahead and ground this here. So this becomes 1, this is 2, this is 3, this is 4. Here's I1, 2, I2, 3, I3, 4, I1, 4. Okay. So on this one here, immediately I don't have to think about that one right there. All right. Now, what two links? Okay, so I don't have to worry about link 1 being there. Are there any external forces on link 2? No. Are there external forces on link 3? What are they? In and out. Are there external forces on link 4? Yes, just the out. So what should your output link be on this? So I'll do it backwards. What should your output link be? 4. What should your input link be? 3. So that's how we determine in and out. Okay? So we're going to use the velocity of I34. So that's this point right here. So to do that, I need to find 1, 3 also. So 1, 3 is found by drawing this line here and this line here. So this here becomes I13. All right. So let's look at link 3 here and draw my forces. So here is the line of action of 3 on this one. And if this thing here is pivoted about I13 and it's moving like this, is omega 3 positive or negative? Negative. So omega 3, you got a minus omega 3. All right. Which means that this point right here is moving to the left. Okay? If that point is moving like that right there, then omega 4 is actually moving like this right here. So I have a minus omega 4.